It's a known fact throughout the automotive industry that vehicles are becoming more and more complex. Almost every device in the modern car is operated via an electronic control module. These ECMs are connected via a communication bus, allowing data transfer between each other. Strip away the mechanicals and your car is essentially a computer, hardware and software. Just like Microsoft, vehicle OEMs struggle with software issues and constantly need updates to ensure their vehicles continue to meet emission regulations, as well as addressing product quality concerns. The control module hardware used by OEMs is very similar across brands. Some manufacturers even use the same engine control units across their various models, simply changing the software to suit different operating conditions or engine and driveline configurations. This is generally based around the cost of total bill per vehicle. It's generally cheaper to use an existing product across the entire range rather than develop a new one. This process has spread throughout all manufacturers and has given rise to the global car. The idea of a global car has many advantages, as the manufacturer can tune the vehicle to suit its geographical location. Traditionally, reprogramming a vehicle's control module has only been available to the OEM dealer. This is because each brand has their own specific diagnostic tool for analysing, coding and reprogramming. These tools are very expensive and often hard to navigate. There is also a distinct lack of training in this field outside of OEM dealerships, as access to OEM data and information has generally been restricted to the dealer. These are just some of the reasons why it's been extremely difficult for an independent workshop to service and repair these vehicles. The independent repairer now has a way of performing the same analysing, coding and reprogramming tasks as an OEM. This is due to the introduction of Pass-Thru. Pass-Thru is a method used to transfer data between a vehicle's control module and a laptop or a scan tool. A pass-through device or vehicle communication interface is used for this data transfer. Be aware that the VCI is a hardware component only. It still requires a program loaded onto the scan tool or PC to operate. Automotive control modules use a different programming language to PC software. The VCI acts as a translator or interpreter between the PC and the vehicle communication network. You may have heard of a VCI referred to as a J2534 device. Well, in fact, J2534 is an interface standard designed by the Society of Automotive Engineers. The standard requests that all manufacturers use conventional methods of data communication and allow independents the ability to reflash emission-related vehicle control units. All OBD2 compliant vehicles must use one of the SAE specified protocols. This simply means one interface tool can be used for multiple OEMs. There are two parts to this standard. SAE J2534-1 was originally developed to allow independent vehicle repairers the ability to reprogram, update and configure emission-related control modules only, without the need for an OEM-specific tool. J2534-2 may be used for diagnostics, reprogramming and updating on all OEM-supported control modules and not just emission-related. Vehicle communication networks are growing in number and complexity. Even basic vehicles with very few product options can have several control modules connected to one of its networks. These control modules manage multiple systems that require constant and real-time data exchange. New vehicles may have up to 5 separate communication networks. Standard J2534 dictates that any pass-through device must be able to communicate with the different protocols used by these networks. Let's have a quick look at some different automotive languages or protocols and their communication networks. Keyword: KWP2000 or K-line uses the UART language, which stands for Universal Asynchronous Receive and Transmit. In layman's terms, this means only one message can be sent and received at any given time. UART has a very slow data transfer rate. This is around 10.4 kilobytes a second. Data transfer is through terminals 7 and 15 in the vehicle's DLC. UART is an older language now and not readily used in current vehicles due to its low speed. Another language or protocol is J1850. There are two versions of this protocol. Both use pulse width modulation for data transfer, but J1850 VPW is able to vary its transfer speed. It's 4 times faster than UART and much more common. J1850 uses pins 2 and 10 to communicate with the VCI. LIN, or Local Interconnect Network, is a broadcast serial network comprising of one master and typically up to 15 slaves. All messages are initiated by the master with at least one slave replying to a given message. LIN devices are generally not connected to the vehicle's DLC, but can be accessed via the network gateway. In most cases, this will be the vehicle's body control module. LAN, or Local Area Network, is a single wire network used for systems that do not require high data transfer rate. This network is perfect for comfort and convenient systems. The LAN network is accessed by Terminal 1 in the vehicle's DLC. Data transfer speeds are in the vicinity of 33 kilobytes a second using voltages from 0 to 5. The CAN, or Control Area Network, is available in medium or high speed, with data transfer rates of 250 kilobytes a second and 500 kilobytes a second respectively. The powertrain network is connected to pins 6 and 14 of the DLC. The chassis and infotainment bus will use other terminals designated by the standard J2534. Different manufacturers may use different names and voltages for CAN, but they all derive from Bosch. CAN is perfect for real-time data exchange and pass-through reprogramming. MOST, or the Media-Oriented System Transport data bus, is specifically designed for the transmission of audio and video data. MOST commonly uses fibre optic technology, transmitting at speeds up to 150 megabytes per second. This network is not connected to the DLC, but can be accessed via the communication gateway. The FlexRay communication network is utilised for advanced stability control and safety systems. This area demands higher speed communication than any current or existing controller area network bus can provide. FlexRay is an alternative to adding more than one CAN network to a vehicle. Due to the data transfer rate of around 10 megabits per second, congestion on the network is no longer a problem. All J2534 compliant pass-through devices must be able to recognise the vehicle's designated protocols and interface with the vehicle's communication network for data transfer. Now that we know the difference between a VCI device, SAE standard J2534, and a vehicle communication protocol, it's time to access the OEM Information and Data Portal. This is where we'll find the required API or Application Program Interface that will need to be downloaded to either a personal desktop, laptop, or even a quality scan tool. It's the responsibility of each OEM to maintain and update these portals and keep current applications available for download. If you need to access these portals, a fee set by the OEM will apply. These charges will vary between manufacturers. Some pass-through manufacturers offer handy software that supplies links to OEM information and data portals. There are two main types of vehicle reprogramming events we can perform with a pass-through device and the OEM application: a software calibration or a firmware calibration. So we all know what software is, but let me clear the air about firmware. Firmware is the control module's interface between the software calibration files and the control module hardware. Think Windows for your PC. The PC operating system is similar to the vehicle control module firmware. A calibration or update to the firmware will mean a complete erasure and reprogram of the control module's memory. This may be needed to overcome an embedded problem within the module. Let's look at some of the basic requirements needed when using Pass-Thru. A high-speed, reliable internet connection is a necessity when reprogramming a control module. This is because the OEM application needs to be connected throughout the process. Make sure that you have the laptop or scan tool connected to the router via an Ethernet cable and hardwired to the vehicle when downloading these calibration files. I would not recommend wireless download and reprogramming. It's far too easy for the data transfer to be interrupted or even corrupted. This is both frustrating and time-consuming as the process must be restarted from the beginning. On some new vehicles, it's not uncommon when performing reprogramming functions for the current draw on the vehicle's battery to be around 70 amps. A 10-minute reprogramming event with this much drain would cause the battery voltage to drop to critical levels. This could be disastrous to the module receiving the update or new calibration file. The module may be unrecoverable. A power supply able to deliver a constant 70 to 100 amps is a must when performing these tasks. This first insert is a scope trace of an average battery charger connected to a vehicle. You can see how the voltage ramps up and down erratically. If this device was used when reprogramming, a serious fault may be induced. The programming code can be compromised and the module will end up in the bin. This next trace is of a quality power supply. You can see the voltage is stable with no fluctuations. This is what's needed for pass-through programming. Control module coding has many different names and has many different ways to be performed, but it's essentially the same across all OEMs. When new software is installed to a control module, it needs to be relinked or initialised and reconfigured to the rest of the vehicle's network. This handshake might reinstall security parameters to the module, record the vehicle identification number, perform RPO or variant configurations, or even perform relearn procedures.
Hey Clint, do I still need a scan tool when using a VCI?
Yes you do, Zach. Not all manufacturers give you access to their diagnostic software. They will allow you to reflash, update or calibrate, but a quality scan tool will still be required for diagnostics, clearing codes and resetting system values, or even performing relearn functions.
So Clint, how long would it take to reprogram a control module?
Well Zach, a newer vehicle using a CAN protocol may take up to 2 minutes for a calibration update and up to 3 hours for a firmware reflash. An older vehicle using a slower protocol could take 3 to 4 times as long. Again, it depends on the calibration file size, total number of calibration files, and the quality and speed of the internet connection. Using a VCI and an OEM application interface is not a hard task to master. The challenge for independent repairers will be having access to the OEM information and data platforms needed for reflashing operations. My best advice is to plan ahead. Try to book like vehicles on the same day so you only need to purchase a one-day OEM software license. Don't be afraid to charge the customer for this service or your knowledge. Thanks for watching.